So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic electric field. So guys, this video will be about concepts of electric field intensity, and electric potential. So in short, to stay till the end of this video. Let's go ahead and start with the first question here. It says, the diagram above shows the resultant electric field pattern due to two electric point charges P and S. Which of the following statements is correct? So option A, both P and S are negatively charged. Option B, P is negatively charged while S is positively charged. C, P is positively charged while S is negatively charged. D, both P and S are positively charged. So guys, recall the conventional flow of current, and here you notice that the charges are actually pointing inwards. So you see the arrows pointing inwards here. So you notice that both P and S are negatively charged. So that's it for this question. Let's go ahead and consider the next question. That's question number 2 here. It says, a charge of 1.0 times 10 to the power of negative 5 coulombs experiences a force of 40 newtons at a certain point in space. What is the magnitude of the electric field intensity at the point in Newton per coulomb? So guys, let's go ahead and solve this out together. The electric field intensity here, E, is going to be F over Q, where F is the force, which is 40 Newton, over Q here, which is 1.0 times 10 to the power of negative 5. So guys, this will actually be resolved as 40 times 10 to the power of 5 over 1.0. So invariably, this is 40 times 10 to the power of 5. And guys, this is same thing as 4.0 times 10 to the power of 6. And that's it for this question. Option B is the answer to this question. So let's go ahead and consider the next question, guys. So the next question here is question number 3. It says, so here we have a diagram actually, and the question says, the diagram above illustrates two charged bodies, X and Y, separated by a distance R. Each body has charge Q and mass M. Which of the following statements about the electrostatic force E and the gravitational force Fg acting between the bodies is correct? So guys, looking at this, option A says Fe is attraction while Fg is repulsion. B, Fe is repulsion while Fg is attraction. C, both Fe and Fg are of attraction. D, both Fe and Fg are of repulsion. So guys, option B is the answer to this question. Fe is repulsion while Fg is attraction. So let's take note that the force of gravity is actually that of attraction, and then the electrostatic force here can be that of attraction or repulsion depending on the charges. Here we have two like charges, and we know that obviously like charges repel. So in this case, we have a negative Q here and a negative Q here showing like charges, and that will be of repulsion. So Fe is that of repulsion while Fg is that of attraction. And that's it for this question, option B. Let's go ahead and consider the next question, guys. That's question number 4 here. It says, which of the following statements about the properties of the electric field produced by charged parallel plate is not correct? We have A, the electric field in the region outside the parallel plate is 0, except for the edge effects. B. The magnitude of the electric field strength and any point between the plates except near the edges depends on the magnitude of the charge on each plate. C. The magnitude of the electric field strength at any point between the plates is directly proportional to the magnitude of the charge on each plate. D. The electric field is uniform everywhere in the space between the parallel plates. So guys, the answer to this question is option C here. The magnitude of the electric field strength at any point between the plates is directly proportional to the magnitude of the charge on the plates. So guys, this is not correct for the properties of electric field produced by charged parallel plates. So, and as such, that's the answer to this question. So that's it for that question, guys. Let's go ahead and consider the next question. That's question number 5 here. It says, use the information below to answer this question. Alright, we have here an isolated metal sphere of radius r carrying an electric charge Q is situated in a medium of relative permittivity epsilon r. A test charge is placed at a point P, distance r, from the surface of the sphere. Let epsilon naught represent the permittivity of free space. The magnitude of the electric field intensity at P is given by the expression A Q over 4 pi E naught ER R squared, B Q over 4 pi E naught ER into R minus R to the power of 2, C Q over 4 pi E naught ER into R capital R plus small r all to the power of 2. Then D, Q over 4 pi E naught ER R squared. So guys, the answer to this question is option A, and that's Q over 4 pi E naught ER times the capital R squared, where the capital R is the radius of the isolated metal sphere. So that's it for this question, guys. Let's go ahead and consider the next question. So that's question number 6 here. The question says, an electron of mass m and charge E enters a uniform electric field between two metal plates P and Q separated by a distance d. P is maintained at a potential difference V while Q is added. Determine an expression for the magnitude of the acceleration of the electron through the field. So guys, for this we have to take note that electric field strength is actually V over D. So electric field strength here is equal to V over D. So with this, we know that the force on the electron is going to be EV over D. So now that we've obtained the force on the electron, which is EV over D, now we also need to consider the Newton's second law of motion, which has it that force F is equal to mass times acceleration, that's ma. Now from this we can deduce that A is equal to F over m. So with this, since we have our force to be EV over D, so from this equation we can state that A, which is the acceleration, is equal to EV over D times 1 over m. So if we multiply these out, we're going to have EV over md. So the correct answer to this question, guys, is option A here, EV over md. So that's it for this question. Let's go ahead and consider the next question. So the next question here is question number 7. It says, calculate the electric potential at a distance of 20 cm from a point charge 0.015 coulombs placed in air of permittivity. So take 1/4 pi E naught as 9.0 times 10 to the power of 9 Newton meter square per coulomb square. So let's take note that this 1/4 pi E naught is actually the Coulomb constant here, and we're going to use it to just solve using this simple equation. So V, which is the electric potential, is KQ over R. So where K is actually this Coulomb constant, which is 1/4 pi E naught. So with this, we're going to have 9.0 times 10 to the power of 9, then times the charge Q, which is 0.015 coulombs. Then this will be over R, which is the distance. Here, the distance is given in cm, so we have to convert this to meter, and that will give us 0.2 meters here. So with this, we have 9.0 times 10 to the power of 9 times 0.015 over 0.2 meters. So having this, we can now go ahead and check this out on our calculator. So that's 675 million here. That's 675 times 10 to the power of 6. And this is same as 6.75 times 10 to the power of 8. And that's it for this question. So option B is the answer to this question. And that's it for this question. Let's go ahead and consider the next one. So that's question number 8 here. It says, the force per unit charge experienced at a point in a field is the A, gravitational field strength, B, electric potential, C, electric field intensity, D, electric field strength. So guys, the answer to this question is option C, and that's electric field intensity. So let's go ahead and consider the next question, guys. That's question number 9 here. It says, the diagram beside illustrates an isolated metal sphere carrying charge W in a medium whose permittivity is E naught. The magnitude of the electric field intensity P can be expressed as A, Q square over 4 pi E naught R, B, Q square over 4 pi E naught R squared, C, Q over 4 pi E naught R squared, D, Q over 4 pi E naught R. So guys, the answer to this question here is option C, Q over 4 pi E naught R squared. So let's go ahead and consider the next and last question here, guys. That's question number 10 here. It says, a charge of 2.0 times 10 to the power of -5 experienced a force of 80 newtons in a uniform electric field. Calculate the magnitude of electric field intensity. So guys, let's go ahead and do this together. Electric field intensity here, E, is equal to F, which is the force, over Q, which is the charge. So the force here is 80 newtons. That's 80 over the charge, which is 2.0 times 10 to the power of -5. So guys, as usual, we can do this as 80 times 10 to the power of 5 over 2.0, right? So this will be 40 times 10 to the power of 5. And guys, that's 4.0 times 10 to the power of 6. And that's it for this question. Option D is the answer to this question. And that's it, guys. So this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.